May I call Mr. Mark Schleifstein to the podium and ask him for his remarks? Mr. Schleifstein is a journalist, as we all know, with the Times-Picayune here in New Orleans and co-author of Path of Destruction. And his remarks yesterday on the bus were so informative that we eagerly await your text.
Okay, somebody's going to have to help me get my slideshow up, I'm afraid. Oh, I've got it. Okay.
Good.
Got it. I can find.
Excuse me. No, I'm going to go right out to business. We have to film. They were truants.
So I'm going to talk a little bit about oil and gas and Louisiana's wetlands and the effects that oil and gas have had on the state. And to do that, I'm going to talk a little bit about where things are today and how we've gotten here. Y'all are, I think, a little bit familiar with this map. It's been shown several times today. Our wetlands are disappearing fairly rapidly. As you can see, this is a photo that we took for a series that we did a couple of years ago. At the top of the picture is the coast, and at the bottom of the picture is the city of New Orleans. And that coastline, you can see, is now very, very, very much cut up. Over time, our coast has been changing rapidly. It was growing rapidly as the Mississippi River moved back and forth, and then when man decided to master the river, it has been losing its wetlands over time. And that's basically a reminder of where we are. This shows where much of the loss has been occurring in the last 70 to 80 years. And so we have to talk a little bit about the causes of wetlands loss and where oil and gas fits into that. There are indeed two different types of loss that are occurring now, both natural and man-induced. And wetlands does play a role in that. Louisiana's had a love-dislike relationship with the oil and gas industry since the discovery of oil and gas deposits in the state in the early 1920s. Much of the state's economic history is tied to oil and gas production, occurring in its coastal zone, and more recently in deep water portions of federally controlled waters in the Gulf of Mexico, and to the refining of petroleum into fuel and chemical products, both along the Mississippi and in the Lake Charles area on the state's western side. The state's coastal zone also is the entry point for about a third of the nation's imports of oil and natural gas, which are unloaded and piped or reshipped to locations around the nation or refined into other products in the state that are used both nationally and are exported back out to other countries. The search for hydrocarbons quickly moved from dry land into the coastal wetlands as producers investigated the relationship of oil and gas deposits and the underground salt dome formations that dot the coast. To reach the exploration and production sites, oil companies dug canals to navigate through the wetlands, and as the fields were developed, the canals for pipelines quickly followed. Today, there are more than 50,000 oil and gas production facilities and more than 9,300 miles of pipelines cutting across our coastal area. Many of those canals now allow salt water from the Gulf of Mexico to move well inland into freshwater areas, especially during droughts and storms. In addition to the direct loss of wetlands to form the canals, the dredge material from the canals has often been used to build canal banks, much higher than the natural marsh surface. The canals and canal banks have dramatically altered the hydrology of the coastal area, causing changes in ecological processes, including disruption of sediment transport, chemical transformations that occur within the wetlands, the vegetation's health, and migration of organisms, including juvenile stages of fish. The canal banks create impoundments and partial impoundments that result in fewer but longer periods of flooding, which also results in waterlogged plants that often die. Sediment resuspended by storms also is blocked, reducing its ability to elevate coastal land. Until earlier this month, the most authoritative study attributing causes to land loss in Louisiana's coastal zone was one conducted by the late University of New Orleans geologist Shea Penland and U.S. Geological Survey geologist Jeff Williams in 1998 that studied the loss of 690,931 acres of land that were converted to water between 1932 and 1990. And you see the results of that study on the screen. The study found that 31% of that loss was caused by natural processes, while 69% was caused by human processes. Submergence from altered hydrology, subsidence, waterlogging, failed reclamation, and herbivory resulted in 54% of that total, while erosion by waves caused by storms, shipping, and channel flow was responsible for 31%. And then direct removal, basically digging out the canals for oil and gas and also the navigation channels, was responsible for about 15%. The combination of direct removal and altered hydrology caused by the oil and gas exploration and production, when you put that together, it turned out to be about 36% of the total loss, or about 390 square miles. A newer study for the Federal Minerals Management Service confirms many of the findings of the Penland study concerning the contributions of oil and gas exploration and production for wetland loss in Louisiana and for all other Gulf coastal states. It concludes that the construction of pipelines related to oil and gas production in the outer continental shelf of the Gulf of Mexico, quote, can cause locally intense habitat changes, thereby contributing to the loss of critically important land and wetland areas. The report is part of ongoing research by the Minerals Management Service to understand the effects of production of oil and gas in federally controlled Gulf waters. Louisiana officials have long argued that the federal government should share a financial burden, a greater financial burden, in restoring coastal wetlands and land areas, specifically because of the effects of such offshore development. For the study, the authors used computer models to interpret satellite and other data, gauging the impacts of pipelines and navigation channels on coastal areas in Louisiana, Texas, Alabama, and Mississippi. They also conducted more in-depth reviews of the effects of individual pipelines and man-made canals. And the study found that in Louisiana, the Outer Continental Shelf pipelines covered 1,187 square miles of wetlands and land, and the navigation channels covered 338 square miles. That represents about 11% of Louisiana's coastline. The biggest impacts were found to be the greater loss of wetlands and lands associated with the Outer Continental Shelf related pipelines and canals in Louisiana and in Texas. The effects varied according to the construction methods used. Indeed, dredging of flotation canals, for instance, for moving equipment back and forth to the wellheads, caused far more damage than just installing pipes by using what's called a push-pull method in narrower ditches that were backfilled, or by using directional drilling to put the pipes underground. In case of directional drilling, a pipe is placed into the ground beneath the marsh and soil surface using horizontal drilling rigs. It only requires the removal of soil or marsh at the point where the pipe enters and exits the ground. The report found direct impacts from dredging and indirect impacts from the construction methods of canals and spoil banks, and they included the altered flooding patterns, as we heard before, and the report also concluded that those impacts can be greatly minimized or avoided with proper application of mitigation techniques. The report also suggested that the cumulative effect of hundreds of pipelines contributes to regional trends in land loss as well. For navigation canals that are still being used for petroleum exploration or by other boat traffic, The report concluded that direct impacts may be difficult to avoid, but keeping the canal banks in place and building wetlands with material dredged from the canals during maintenance dredging can mitigate damaging effects. The report also found a strong relationship between the time when these canals were actually built and the kinds of damage that are seen today. The reality was that the biggest damage occurred immediately at the time when the canals were built and occurred over a broader area. In Louisiana, that loss is consistently higher near the pipelines than the regional loss rates for areas outside the pipelines. The loss rates also were, like I said, highest soon after the pipelines or canals were built, and then dropped off in the later years. Higher wetland loss rates in Louisiana's deltas are explained in part by that high density of pipelines, including the large number of open pipeline canals combined with a high rate of subsidence in the area. So let me tell you a little bit more about some of the other causes of loss. The key ones that also exacerbate the problems of the oil and gas canals are that we are losing the sediment. Lots of the sediment goes out the river and does not go back into the wetlands to replace the sediment that's been lost by things like pipeline canals. We also have problems from natural causes, including hurricanes. 217 square miles of wetlands were lost during Hurricanes Katrina and Rita in 2005 alone. Wave erosion, and then subsidence and sea level rise. This is an explanation showing that our subsidence is occurring in the latest portions of the delta that have been created, which are largely the Bird's Foot Delta, the lower part of the existing course of the Mississippi River. And as you move farther back, the rates of subsidence drop off. And then, of course, there's relative sea level rise and the potential that that could cause significant effects. And of course, this particular slide is fairly out of date for what that sea level rise will end up being. River levees are a significant problem, as I said. And then there's the canal and channel dredging that occurs. This is a field that was worked over in the 40s and the 50s, and you can see all the individual little places where canals were dug and cutting away the wetlands. Our industry is significant. This is a photo along one of the bayous of oil and gas production facilities that are stationed there waiting to go out and do additional work. Another similar shot. And here's a good example again of how those canals can cause the problems by changing the water flows. The importance of Louisiana's wetlands, I think you can see from both this slide and this next one for oil and gas. Oil and gas production is intense off of our coast and also on land. And if you think about all those little dots being connected by pipelines, you get a better understanding of the kind of pipeline damage that occurs across the state. An explanation, a little bit of an explanation of different ways that the pipelines can cause problems by capturing water and changing the water flow. The other problem of oil and gas production is that the areas where oil and gas are being produced actually increase the amount of subsidence. And there's some who say that a part of that cause is the result of the pumping activating local sort of semi-earthquakes. Little fault areas are activated and parts of the land drop in blocks. The other obvious problems for oil and gas are direct pollution. This is a photo that was taken of the spill at at the Murphy Oil Refinery. This photo was taken by me 2 days after Katrina from a plane. And you can see all of that brown water is actually water with oil on top of it. The neighborhood that we were at the other day is right behind there. Here's another example. This is a pipeline down closer to the mouth of the river that burst. In this case, this was a pipeline that was owned by Shell Oil, and Shell Oil immediately came in. This is again 2 days after the storm, and started capturing that oil and replacing and repairing the pipeline. Our history of coastal restoration for dealing with oil and gas and other results, you can see has been going on really since 1965 to the present time. And it includes research that's being done at Louisiana State University on how to redesign the mouth of the Mississippi River. It includes the piping of sediment from the Mississippi River back into wetlands to create new wetlands. And it includes dredging offshore to rebuild coastal barrier island areas and coastal headlands. The state and the federal government have been working on combinations of projects. And one of the things that the state also is looking at is using the state's coastline, both the underground oil and gas production areas for storage of carbon as a carbon reduction idea, and also attempting to use the growing of cypress forests as a carbon storage idea for carbon credits. And then there's the question of best available technology in future development of oil and gas. This is actually a landing craft that is built here in Louisiana that is a hydrofoil. It goes above the wetlands, and you wouldn't have to build canals if this were used. The state, however, and the federal government do not have a requirement that the best available technology be used for oil and gas production. These things are built in Louisiana and would be a boon to our economy and also help save on damage to the coast. And I think a lot of the problems that we deal with in the future, in our immediate future, are going to be at this guy's table. This is a photo of the president during his campaign when he was here in town enjoying a good meal that was largely created in our wetlands. And I think I'll end with that. Thank you.
Thank you, Mark, for that acute and penetrating look at a local piece of the global commons. May I ask for questions for Mr. Schleifstein? Please, Graham. And again, if I could encourage all of us to be concise and to respond in the same manner.
I just want to commend you for identifying the fact that while many Louisianans claim that there's been sea level rise, really it's been subsidence. And this is confusing a lot of people. The future will be sea level rise, but historically it's subsidence, isn't it?
It is a real problem in Louisiana to understand that our wetlands loss problems are largely a combination of reasons that include both the natural subsidence that's occurring and the sea level rise, both natural and that is being increased by global warming. And parsing out what those numbers are is very difficult. The reality is that our sea level rise in this state will be much higher than most other areas of the United States because of that subsidence factor. I forgot at the beginning that I really would like to thank Your All Holiness for coming here and bringing this conference to New Orleans to point out the problems of the world's environmental issues in the context of New Orleans and Louisiana. It's been very helpful to us to get that sort of an international stage for our issues, so I want to thank you for that.